Okay, for the next presenters, is it here, Mr. Muhammad Alif Haikal?
He will join shortly. He is here. Yes.
All right, thank you. And then Miss Nurul Adila, isn't it? So,
Yes, I'm here.
okay. And then of course, ini saya tak kenal ni, Dr. Nur Bidawati.
I'm here.
Okay, all right. So we wait for about maybe 1 to 2 minutes more. Okay, kita tunggu sekejap. Baik, bismillahirrahmanirrahim. Alhamdulillahirrabbilalamin. Wassalatu wassalamu ala asyrafil anbiya'i wal mursalin wa ala alihi wa sahbihi ajma'in. Subhanaka la ilma lana illa ma 'allamtana innaka antal alimul hakim. Rabbi shrah li sadri wa yassir li amri wahlul 'uqdatam min lisani yafqahu qawli. Assalamualaikum warahmatullahi wabarakatuh and very good afternoon to all the presenters. So basically, I would like to welcome all of you to the third Global Congress on Construction Materials and Structural Engineering that is known as GCOMSE 2021. So my name is Ahmad Fahmi bin Kamarudin and truly virtually for this GCOMSE 2021. So thank you for choosing GCOMSE 2021 as a platform for you to share your research experience and engage with some from other researchers. Okay, so before we start, I would like to remind to all presenters so that if you could fill up the attendance, okay, using the link that has been given in the chatting box just now. And then for those who like to claim your CPD hours, okay, whether you are claiming it from the MBOT or from BEM. So you may do so by downloading the CPD form from the website and then upload it back in the attendance form. Okay, so as for a reminder, okay, so you will be given for a 10 minutes of presentation and then followed by the 5 minutes Q&A session. Okay, so basically we have plenty of time, okay, because we only have 5 presenters only. And then as a warming up the opening session of this GCOMSE 2021, hopefully this presentation, so you can grab some of the experience. You can maybe you can share some of the experience based on your research, and then we can have a sharing session. So along this presentation session. Okay, without further ado, I would like to welcome our first presenter today, TS Dr. Yasmin Saho. Okay, so maybe you can start share your slide. TS Dr. Yasmin Saho Hamid from School of Civil Engineering, College of Engineering, University Technology Mara. So she All right, thank you. Okay, so her research is on the title of optimization of bolted connection in steel core belt attached to the RC column of MRT viaduct. So, doctor, this virtual floor is yours.
Okay, thank you to the chairperson. Okay, Assalamualaikum and a very good evening. Okay, my name is technologist Dr. Yasmin Sahul Hamid. I am currently a lecturer at University Technology Mara UITM at College of Engineering, and I'm teaching structural engineering. So basically for today's presentation, I'm going to present to you on a topic titled Optimization of Bolted Connection in Steel Core Belt Attached to RC Column of MRT Viaduct. Okay, so just to introduce to you about my team members. Okay, here my team members is Dr. Hazrina Mansoor, who is a senior lecturer at UITM. Puan Nur Safarina Ahmad is also a senior lecturer at UITM. And then we have Haikal Ajmal, who is a project manager at Flip Space Sendirian Berhad, and Amir Atif Abdul Razak, who is a site engineer at Mobile Baroko Sendirian Berhad. So all of these members are contributed to this research topic. Okay. So let me begin my presentation, okay, with the introduction. So basically, MRT, or also known as a mass rapid transit, is considered as one of the country's largest ongoing infrastructure project and is considered to be one of the backbones of our city's public transportation system in Malaysia. So the city will be a gridlock if everyone drove. Exactly right. So the Klang Valley requires an MRT network, and this type of transportation system in Kuala Lumpur is expected to help to ease the traffic congestions by increasing the number of people using the public transportation in the Klang Valley. Okay. So, core belt structures usually consist of a segmental box girder. It has a crosshead, it has bridge decks, it has and piers. Okay, and the core belt is used to support important structure elements such as beams and girders. However, it has been found that less research has been conducted on core belt, particularly on the bolted connection part. Okay, so basically, let me just tell you a little bit of a history how this research has been realized. Okay, so basically, this study was actually prompted by questions and concerns and raised by engineers at the Sunway construction. Okay, so these are real situation that is really experienced in real engineering field. Okay, so Corbel in previous design was actually constructed made out of concrete. Okay. However, this core structure is made out of steel. So basically, the steel portal frame needs to rest on the core structure. Okay, why? Because to allow more usable area on the platform, such as a kiosk and other amenities. So basically, the worries that the engineers has is how can it be built to be optimized the steel core belt based on the number of bolts. Moreover, the majority of the existing design was just doing a design software and there was not any second order analysis that was done. So plus there was no actually a proper validation that was done by manual calculation. Besides that, besides those facts, every engineer knows and failure of a connection is considered as one of the most serious cause of failure because it can cause the failure of the entire structure. Okay, so just to add further, what we did was in before we proceeded to this research topic, we also did some questionnaires to get a better understanding of the issue and asking questions and the experience of the engineers involved in the cobalt structure industry. So we distributed a number of survey questions on cobalt structures and we asked them to fill out the survey and give their comments. So from there, many of them offered suggesting to make the existing design to be more cost effective and claiming that it was actually over designed and they feel that more detailed investigation is actually required so that a better understanding and knowledge of the behavior is understood well. Okay, so that is a good reason why this research is very important for us to deliver. Okay, so as a result from these questionnaires and the issue that has been raised by the engineers at Sunway Construction, okay, we found that what we did is we in this study, finite element analysis with using step pro was used to examine the details of the core bell structure bolted connection, but this time the core bell is made of steel, not concrete. Okay, so there was also a requirement to recommend, sorry, so there was also a requirement to recommend what is the ideal number of bolts to utilize in the MRT station, as well as the crucial inspection to ensure that the connection were actually working properly. So this study actually has enabled the design and engineers in particular to have a much more thorough check on their design, since their research has since research this research has been considered to be valuable and beneficial to the industry, as basically the research-based studies in the industry are rarely conducted. Okay, so there were three goals that we wanted to achieve in this study. In other words, we wanted to determine the optimal number of bolts used to connect the steel corbels. Secondly, we want to compare manual calculation with the shear, bearing, tension, slip, and block tearing resistance of the connection. And finally, we want to recommend the number of bolts based on the stress distribution of the design. Okay, so basically that is what we want to do, and the scope basically has already been mentioned, so I'll just proceed to the next slide. Okay, so steel corbels are made actually of a number of elements, including the I-beam as the main structure, the stiffness, the end plates and bolts which are connecting the pier, the portals or the column. In this study, the I-beam section property that we used was 600 UKB 686 times 154 times 170 was used. All the dimensions according to the actual all the dimensions of the steel corbel was actually the same to the actual dimension of the corbel structure at the site. Okay, and the proposed type of bolt that was used in the connection of the corbel was grade 8.8 M24, which shows a diameter of a bolt to be 0.024 mm. The corbel structure elements such as the web section, the flange section, the stiffness, the end plates, and the bolt structure are all made of steel. It is assumed that the strength of concrete in the study was used as 4,400 kilonewton per meter square. The portal frame model utilizes in study was actually from students that compete in MSSA CIDB Open ID competition with the theme of Reimagine MRT Station. So what we did was we remodeled the MRT portal station into StartPro software to determine what is the maximum loading of the portal frame and imported it into our loading for the core bell structure. Okay, so basically, next, the four parameters that were considered in the study is to determine what is the best design of the steel corbel. And the four parameters have been proposed are the bolt design arrangements, the configuration, the diameter of the bolts, the dimension of the end plates, and the web thickness of the beam. So as you can see, to optimize, there's a lot of numbers of parameters that we need to consider. Okay, so this shows some results that was achieved, the stress distribution contour, considering different number of bolts. Okay, so the ratio of the number of bolts has their own significance and reason why we have selected. You can read further into the details of the paper why it was selected. However, just for your information, the configuration of the 24 number of bolt represent the original design that was suggested by the engineers. Okay, so it is critical for us as an engineer and design engineer also to optimize and ensure that the most effective and functional optimized strength is used for the bolted connection of the steel corbel structure. That is why the bolt, the thickness of the plate, the beam, the web, and all are also molded with various size and thickness to achieve the most optimal design. Okay, as you can see from the study, it was found out that 18 bolts and 24 bolts design are satisfactory, as you can see in this table. But for optimization purposes, 18 bolts design can be selected. Okay, it's already good enough. Okay, and then we also did a number of hand calculations, okay, that was conducted based on the Eurocode 3 design of steel structures, part 1.8 design of joint detail. As you can see, the table here shows a summary of all the checks that has been conducted, the shear, the bearing, the tension resistance, slip resistance checks, and these are all the results that have been compiled, okay, for us to understand better in deep on the understanding of the behavior of the bolt connections. Okay, right. Firstly, what we found out is the clearance and the bolt positioning are checked in terms of bolt clearance, bolt positioning, maximum end and edge distance, and minimum and maximum spacing. And secondly, the bolts are tested against several aspects, which are shear resistance, bearing resistance, tension resistance, and slip resistance. Thirdly, in order to ensure that the end plate is adequate to resist shear force, the capacity is tested in terms of shear resistance, cross and neck section, and shear resistance of web and block tearing. So from the result, it was found that the bolt numbers passed the clearance and bolt position check. So this kind of check is actually is very good for the reassurance for the engineers. Okay, so usually in a real construction engineering firm, besides doing the design using a software, manual calculation is also required for checking, and doing various sizes makes us more confident that the size proposed is sufficient enough. Okay, right. So here are some discussion and conclusions. So I'm going to say. So basically, the study achieved all of its goals. We also compare Eurocode and British standards loadings analysis. The maximum core loads were evaluated using a portal frame modeling using Eurocode. The Eurocode delivered 10% less transverse force, vertical force, and transverse moment compared to the British standard in StatPro. A design reference based on Eurocode can thus be optimized. Goal was to improve the steel core bell bolt connection, which we did, and this reduces the number of bolts used in steel core bell design, that is from 24 to 18, and the reduction in bolt diameter of the end plate thickness was found from 24 to 18 is actually possible, and the 15.4 web thickness can also be reduced up to 11 millimeter. And manual computation for the connection, shear, bearing, tension, slip, and block tear resistance, and the study of stress distribution, and can offer the best steel core bell design, and the stress distribution control was able to achieve from the FEA output, and the red maximum stress distribution from the 18 bolt core bell analysis showed that it does not exceed the 355 Newton per squared stress. Okay, and it can bear the shear, strain, and slide. However, we have found out that the 15 end plate can also tolerate both the gross and net shear effectively, and the 11 beam web also resists the shear, was able to resist the local shear. So basically, all this result and optimization value that we have achieved can actually be used as a very good guidelines for design engineers in order for them to do the thorough checking. Okay, so in conclusion, the study suggests that steel core bell structure can be modified to save cost while actually still resisting the design loads. Okay, so that's the end of my presentation. Okay, thank you.
Thank you very much, Doctor. So it's a good presentation, basically, lots of information inside there. So now I open for these virtual floors for any question and answers session. Any question from the audience? Basically, Doctor, how much the percentage, how many percentage that has been reduced when you reduce the number of the bolts, then the strength is also acceptable. So what are the percentage basically?
Well, basically from 24 numbers, actually we can use 18 numbers of bolts is already acceptable.
Acceptable,
Yes, acceptable,
and then in
and it
terms
can
of the
tolerate
strength, in terms,
the same amount of strength is used, and it can tolerate the same amount of strength.
Correct, because
Mm.
basically for this high tension bolt, they sell by pieces. If you try
Mm-hmm.
to buy this bolt, it sell by pieces, not by the weight.
Mm-hmm.
So it will reduce lots of the cost basically.
Yes, definitely. Yes.
Mm,
So this research guideline is actually very useful for the engineers because basically they are the one who proposed this idea to conduct this research. Mm.
mm.
So I'm happy that they found it useful.
All
Mm.
right, so it's very
Okay.
interesting research.
Okay.
Basically, doctor, you remind me this voice is similar to Puan Sri. So saya
Oh,
mereka to Puan Sri.
okay. You actually look very familiar. Uh, uh,
Uh, all right, so saya
yes.
mereka to Puan Sri. All right,
Okay.
so
All right.
I open again for any question from the floors. Any question from the presenter or from the participants? Yeah, please go ahead, Dr. Zainu.
Assalamualaikum. So my name is Zainul Rizwan. So my question to TS Dr. Yasmin regarding the optimization of the boat. So basically by reducing the number of boat. I believe it's actually almost 50%, right, in terms of the total number of boat. But basically, uh, to retain such a good capacity and rigidity, uh, when you're reducing the number of boats, so it will be affecting like the distance, the pitch distance between boat to boat. So based on so-called preferable guideline in EC3, is it this kind? If you have the distance of the boat
Yes.
so high, so is it they have effect to the ductility on the uh, plate that actually connected to the steel boat? And then
I
how about the the so-called if we go for the post failure under such a extreme condition, so is it the crack propagation or the failure mode, okay, could be have a similar condition with the original design of the steel boat? This is my question.
Mm. Okay. When you talk about the penetration, I think you're asking me how deep is the bolt into the concrete, isn't it? Well, basically, in this study, we what was proposed was actually 600 millimeter deep, but however, it has been revised to 800 millimeter deep, and that was what we analyzed in our research. The deep. I think what we need more study is to observe the various depth of the bolt, because that is actually a good idea. That is something that we did not do because we wanted to maintain the original design how they have proposed the depth of the bolt. But what we do is we change the other items. But considering what you said, the how the depth penetration can affect the durability and everything has a adverse effect. Yes, I agree, and I think that would be a very good continuation for the research. But for now, we had maintained the penetration depth of the bolt to be one value. Was one of the items that we maintained because we wanted to maintain the original original sketch drawing based on the real site. Okay, and then your second question, you asked about the effects of crack. Okay, for that is a very interesting. However, we did not conduct that kind of test, and of course, it's of a concern because before this, the corbel segmented pier and the corbel was concrete, so that had a good bond between them, right? Now, because the MRT they wanted to use steel corbel, that's why the engineers have worry and concern of that issue. And for the crack propagation that can occur is something very interesting. However, that requires a more sophisticated analysis software, which we need to use Abacus or ANSYS, which we did not go to that detail. But however, that is in the recommendation detail in our research to further. And I think that could be something very good to continue. But however, I do not have the answers for that part. But there is concerns on that. I hope I'm answering your question.
Yep. Thank you very much.
All right, so thank you very much. So this is the main purpose of this platform. We can share our experience, we can share our ideas, maybe our suggestion and other recommendations. All right, so I think we need to move to the next presenters. Is it Muhammad Amri Gapar is here?
Yes, I am.
Okay, please share your slide. Okay, please share your
Okay.
slide. Okay, so basically, Mr. Muhammad Amri Gafar is from School of Civil Engineering, College of Engineering from UITM as well. So he's going to deliver his presentation, okay, for his research title in Industrial Building System or IBS, in terms of a unique intra-module connection on modular steel building. All right, this virtual floor is yours, Mr. Muhammad Amri.
Hello, Assalamualaikum, and a very good evening to the participant and all the presenters. I am Muhammad Amri bin Gafar, and my paper ID is 036-02A in Industrial Building System IBS, a unique intra-module connection on modular steel building. So the industrial building system, IBS, is the modern method of the construction nowadays. The concept of modularization is one of the prefabrication concept whereby it is a well-known method for every developed and developing country such as China, Europe, United States, and Australia years ago. In Malaysia, there are small and medium company that introduce some kind like modular steel structure that we can see around us. This method is beneficial, workability, and sustainable because it can save money due to less workers on site and also mass production with limited mold, less wastage such as plywood for casting concrete, whereby after a few times it needs to be disposed. A single module is called as a modular. A modular will stack on and side by side each other by connection. The connection is divided by three categories, which is inter-module connection, intra-module connection, and module to foundation. So the intra-module connection is the connection between members in a modular itself. This connection must be rigid enough to cater the safe wake loading from the beam, which is the horizontal member, and also loading from the column vertical member. It consists of both O or N welded connection. So this video is in Wuhan, China, whereby they built their hospital within 2 weeks time frame. It is a good example of management, workability, and time consuming that leads to the successor of the construction. We can see here where the worker loaded modular steel piece by piece and stack on each other and tied with the connection. At first, they built a platform for infrastructure before assemble the modular. They built up the modular at factory before they transport it to the construction site, whereby the frame, the wall panel, the mechanical and electrical being installed at there. So this time, the focus study is on this modular steel building is on the intra-module connection. This is the proposed intra-module connection inspired by a unique architectural hexagonal shape. The hexagonal modular is stacked side by side into 6 pieces and form a solid structure. The idea of this architectural building is being studied, and our team decided to work out on the hexagonal shape with the dimensions as you can see on the right hand side of the slide. The length of a horizontal member for main structure is 2500 mm and the height of vertical member of hexagonal modular shape is 3000 mm. Before going through deep on modeling, our team decided to do the verification of the modeling method. We decided to take an example of single lap joint with a horizontal load of 50 kN exerted to the right, and the model is set up until the elastic limit. The model starts with assemble of the bolts, plates, justification of the boundary condition and the constraint to stimulate as the real conditions. The manual calculation is calculated to get the ultimate shear resistance of the bolt. The result tabulated at down right of the side, as you can see in the blue box here. So from the Abacus software, we get the shear load resistance, which is 49.86 kilonewton, whereby it is less than ultimate shear resistance, which is 60.29. It shows that this outcome result of this verification is good and can proceed to the next model. To figure out the load being carried out by the connection, the model of sub 2000 is being introduced. The property of members in column and beam, which is vertical and horizontal members respectively, is being tabulated in the table at the right hand side of the slide. The components such as C-channel beam and circular hollow section column is being assigned in the model of sub 2000. The diaphragm, bolts and nuts and fin plates is being tabulated to model in Abacus software. So in this slide is the connection that have been proposed by our team. The hexagonal shape diagram is being introduced to suit with the hexagonal member of modular. This part is important to tight between member so it will become rigid and stable. The fin plate is attached at the column by welded connection. Thus, the connection becomes rigid to each other. The C channel is bolted to the fin plate by 4 units of bolt and nuts. The idea of removal of member at the right hand side of C channel is to suit with progressive collapse procedure, whereby it is assumed that the end of the member is being demolished, struck by any unusual phenomenon due to accident or loss of members in the structure. As same as single lap joint procedure, the structure needs to be constrained and restrained to simulate the real condition. The boundary condition is assigned whereby the bottom of the column and left-hand side of the diagram is assigned as encountry and hold the structure at place. The C channel is being restrained as centroid of member where it's allowed to move in y direction and rotate on YZ plane only. The tie constraint is being used to assemble between column and diaphragm, column and fin plate, C channel, and loading at centroid point of C channel. The method for step is on static rigs with initial load 1000 kilonewton downward. So next is the deformation and failure mode of structure is being recorded, whereby the maximum von Mises stress of plate is 357.5 Newton per meter squared. For column and diaphragm, C channel is 429.9 Newton per meter squared. The load displacement failure mode is figure at the right hand side of the slide. The result of the load displacement is being plotted at the next slide. For force versus deformation of bolt and nut, the maximum deformation is 249.8 mm. For plate is 226.09 mm. For C channel is 884.2 mm, and for column is 159.58 mm respectively. So the discussion and the conclusion, so it shows that the highest deformation is at PFC, which is at the C channel, whereby there is part that member is removed, as I discussed at the slide number this slide. So at the end of the C channel, there is a member removal at here. So the least deformation is at plate, whereby it is set as highest grade, which is S355, whereby this plate connection is designed to be strongest part in the structures, because the connection is very important in our model to hold the structure to become strong. So that's all. Thank you.
All right. Thank you very much for wonderful presentation. So I open from the floors for any questions. If you have any question, please raise your hand. All right. Yeah, Dr. Zainul.
Okay, Assalamualaikum. So I have one question regarding your finite element modeling, because you have the structure, like you have the C channel and also the circular hollow section, in which that you mentioned that these two different component is assembled by using the welding, right? It's a welded.
Yeah, welded from the column to the fin plate, and then the C channel bolted to the fin plate.
Okay, so during the modeling in the
Abacus.
in Abacus,
Okay.
is it the welding system or the welded component is a consider, or you are just slightly ignore the effects of welded in your modeling?
Yeah, we consider the welded part as a tie constraint. There's sorry, I will share again my slide. So at this part, the constraint assignment from the C channel to the hollow section column is set as a tie constraint. Tie constraint is the uh, mm, the assignation of where we welded from C channel to the column. So we put the tie constraint in there, that model. So they will read as it is welded each other. Okay, can you get it?
Okay. By the way, I have one more question.
All right.
You use a C channel, right, as a beam, structure beam.
Yeah, right.
Any other specific reason why you use a C channel? Why not T beam or other sides of the section?
Mm, because based on the previous study, more researcher using this C channel, because it can be tied the floor of the building to the C channel, and then it touch each other, because this is modular. So the module, the floor of the building need to tie to one of the member. So C channel is one of the best method to be tied on, and then the load is transferred to the column and to the foundation.
Okay, thank you. Very good.
All right.
Yeah, very.
Right, thank you very much. So, as we know that during this pandemic, of course, you are unable to conduct the laboratory test, isn't it? Have you
Yeah, yeah,
conduct the
yeah.
laboratory test for these samples?
I have another one sample which is intra-module connection. So this is the inter-module connection. Sorry. This is the intra-module connection. I have another one connection which is intra-module connection, which combine from the modular to modular, and the connection we study very particularly lah on the connection. So well, in the pandemic we cannot do the laboratory, so we need to hold on some time
All right,
for me.
all right. So, yeah, Dr. Said, please, you have any question? Please raise the questions.
Sorry,
Please
can I
unmute,
hear you?
unmute.
Oh, sorry. Good afternoon, everyone. Thank you very much for the interesting presentation, Doctor. It's very nice. Just my question is about the final failure mode for the connection. Do you have any idea, anything?
Final. You mean the deformation and the failure mode of the structure?
Yes.
Okay. I can see. Sorry, I will present again. So this is the deformation and the failure mode of the structure. Actually, I do run a model, so it shows that the highest stress is on the what we call the column.
Column.
Yeah, at the column. So we can see here that we can say here that the weakest part in this model is at the column and also at the diagram of the model.
So we can say the final failure mode will be the backlink failure of the at the top. Right?
Yeah. Mhm.
Okay. Thank you very much.
All right. Thank you.
All right, thank you very much. So, I believe we don't have any more questions, isn't it? Okay, so we move on to the next presenter. So I would like to welcome Ms. Nurul Adila Anati Murad. Okay, Ms. Nurul Adila is here, isn't it?
Yes, I'm here.
Okay, so you may share your slide. Okay, Ms. Nurul Adila, she's from Composite Structural Engineering Technology Focus Group. Okay, Faculty of Civil Engineering and Built Environment in UTHM. So the research title is Strength of Modified Form Concrete Fill Hollow Section Using Fly Ash as Sand Replacement. If you are ready, so this virtual floor is yours.
Thank you very much, Ahmad, and greeting to everyone, to presenters and the participants. Okay, now I'm going to present about the strength of modified form concrete, the hollow section. And my name is Guru Adila Anati, and this is my co-author names. And we are from Department Civil Engineering of University Tun Hussein Malaysia. Okay, I am a student of Faculty of Civil Engineering from University Tun Hussein Malaysia, and I'm Guru Adila Anati Murat. Now we go to the introduction. Nowadays, the application of steel in construction has widely used, and the hollow section is steel construction that have been used for decades. This is because the steel has the strong durability and strength. The elongation of steel makes it improve weather steel to prevent the structural to the sudden failure. And the steel section shows the best mechanical compression resistance and the highest bending properties, but it prone to buckling. Therefore, the concrete infill the hollow section in the industry, and it has been practices in the industry. This is due to reduce the buckling of hollow section, as the concrete hollow section can provide the flexural support influence concrete confinements to improve the steel hollow section performance and also to increase the structure. And the application of concrete hollow section from normal concrete hollow section has been improvised to lightweight concrete hollow section, as the normal concrete hollow section increase the structure's dead weight. Therefore, the lightweight concrete hollow section has used the lightweight materials, and one of it is used the foam concrete to reduce the dead weight. And the lightweight concrete hollow section has exhibit the local buckling when a column reach failure, and general buckling will occur. And one of the solution is proposed, which is modified foam concrete hollow section using fly ash as land replacement. And the use of fly ash can improve the durability and also low cost construction. And also it can reduce the dead load and improve the fire resistance. Okay, and this is the material and the experimental work. The preparation of the FCFHS FA is the mixture of the fly ash, preformed foam, ordinary Portland cement, fine sand, water, forming agent, and super fertilizer. And this table is the concrete mix design preparation that has been used in this experiment, where the cement ratio for the foam concrete is 0.5 and for the modified foam concrete is 0.5, while the foam cement ratio for both of the mixture use 0.7 and the water cement ratio is 0.55. However, for the modified foam concrete, it has been used 60% of fly ash, while the foam concrete is 0% of fly ash, and the foam agent is 1:20. And this figure below is the dimension of hollow section used, which use the square hollow section, and with the long length 350 millimeter and the dimension 100 by 100 millimeter. And this experiment has used two different thicknesses, which are 2 millimeter and 4 millimeter. And for the material properties, okay, the strength modified foam concrete after the kit test, it has obtained 22.1 megapascal, and the kit test for the modified foam concrete is for average load value is 220.7 kilonewton. And this kit test was carried to determine the strength of modified foam concrete at 28 days. And the tensile coupon test was carried out to determine the strength of steel hollow section according to the ISO 1698-2005. Okay, and this table 3 shows the tensile strength for the thickness 2 millimeter is 323 megapascal, while 4 millimeter is 376. Okay, for the experimental work, okay, 6 specimens was prepared, which are 3 specimens for the 2 millimeter thicknesses and 3 specimens for 4 millimeter thicknesses. And the bottom of the steel hollow section was covered with the plastic to avoid the concrete water flowing up from the bottom of the steel hollow section. And the modified foam concrete hollow section using the fly ash as sand replacement specimen was then placed on the steel plate by following the concrete casting for this 6 specimen. And the specimen were tested under the compression load at 28 days after the dry air curing by using the dry air curing method. Sorry. Okay. And here is the result and discussion when this table shows the test result and the calculated strength index value. Hence the value from the experiment was compared with the previous study on the foam concrete hollow section. The table shows that the strength modified foam concrete that fill hollow section using fly ash as a replacement of modified from concrete. And the strength of the concrete is higher than the from concrete to hollow section without fly ash. However, the strength index shows a similar strength index between the modified from concrete to hollow section using fly ash and from concrete to hollow section without fly ash. And the strength index value of more than 1 has indicates that the concrete is postponed the local buckling of the steel tube. So we can say that this experiment has delayed the local buckling. Okay, and here is the specimen that shows the typical local buckling failure appearance of the test specimen. Okay, for at left is 2 millimeter thicknesses and right is 4 millimeter thicknesses. And these both thicknesses has shows the local buckling at top and bottom. And it is a common local buckling that occurs. And this specimen for concrete roller section with fly ash for 2 millimeter thickness. For sample 2, it shows both. Sample 2 shows the bottom local buckling happen, while at the sample 3 shows no local buckling at all. And for the thicknesses, 4 shows top and bottom local buckling for both for 4 millimeter thicknesses. Okay, and this figure has indicates that the local buckling mode on steel hollow section structures 2 millimeter thicknesses is more significant than the 4 millimeter thickness. And the buckling mode on this specimen is also non-consistent. And this appearance can be related the bonding strength between the steel and the concrete. And by referring to the surface irregularity, such as roughness of steel section or surface of a concrete cross-section, along with the specimen size and its effect of the bond strength. And from the study, it can be concluded that the use of fly ash as sand replacement to form concrete does not show large improvement in strength. However, it does show the bonded between the steel and concrete, which the strength index more than 1. And therefore, for one recommendation for the further study can be conducted is by adding the fiber to improve the strength of modified foam concrete using fly ash as an replacement. And that's all for me. Thank you.
Right. Thank you very much for the presentations. So I open for any questions, okay, among the presenters and also the participant. Dr. Wirda. Okay, baik. Silakan Dr. Wirda.
Okay, Assalamualaikum, Nurul. I have two questions. The first question is, do you observe any failures on the concrete? The second question, the theoretical values and the experimental values, some of the specimen give a quite big difference, right? So what are the costs or the parameters that contributed to that different or big difference? So that is my two questions.
Thank you, Dr. Vida. Okay, for first question is the concrete failure. Okay, for the concrete failure, I'm sorry. The cube test has been observed on the cube test, and a few failures occurs on the cube is crack. It's a crack and at the edges of the cube. And we also have observed the cube test. And for
Beside cube test,
uh-huh.
at your specimen, the 2 mm, the 4 mm specimen, the column, do you observe any failure on the concrete? Do you can see any maybe I don't know how you maybe observation on the concrete inside that? Can you see any any failure on the concrete, or is it the failure is on the steel only?
Yes, the failure only on the steel. However, on the tube it shows failures, but it just shows a small crack and at the edge and at the sides of the tube.
Okay.
And for the second question is I try to present that here. The difference between the theoretical value and the experimental value, isn't it? Okay, yes, it does shows quite big difference between the theoretical and experimental value. And from my observations, the difference between can it give a few causes, which but it also regarding to the during the construction itself, and means there might be a slightly an human error during the construction. Either even though we are have following the concrete in its design, and but it can cause the differences between both theoretical and experimental value can happen due to the human errors itself, either during the not sequence of the mixture or the preparation itself. Thank you. There's answering.
Okay. Okay.
All right. So thank you very much, Nuradila. So basically, based on your SI, how you calculate your SI?
Okay. For the SI, having based on for the formulas I have used. I'm sorry. I am referring the design guide where they use to get the MPLRD. We have to calculate the area of the space area. A is area of the concrete with the FC with the compressive strength and divided with the partial factors. And same with the as for the AS, I'm sorry, I'm quite nervous a bit. So, okay, for the NPLRD, the formula is AA times with a FC, FY divided with the partial fraction, partial safety factors, and then plus with the area of the concrete with the compressive strength and divided with the partial safety factors for the concrete, which is 1.15. And while for the steel is the area of the steel multiplied with the Fy, the compressive strength of the hollow section, and divided with the partial safety factors, which is 1.15. And for the partial safety factors, it's regarding based on the Euro code 3, based on Euro code. And after that, to get the SI index, the ultimate the NU ESP, we call the value of experimental, the experimental value. Then we divide with the NPLRD opting.
All right. So it's quite a long equations. So it's good if you can put inside your slide basically, so the audience can see it clearly. So basically, we have another question in the chatting box there. Okay, by Jiang Ui, Mr. Jiang Ui. Is it how to control creeps and shrinkage due to two different materials? Have you done this kind of studies?
No, I have not. It is out of my observation. As during the experiment, there are few obligations is a few obstruction during the experiment as the pandemic have limited my observation, and some of the experiment cannot be conducted as the lab has closed and some of its data cannot be obtained. So this experiment is not be observed here.
Okay, so that's all.
Yes.
All right. So thank you very much for your presentations. I think we could grab something from this presentation as well. And then I think without further ado, we try to proceed to the next presenter. Okay. So our next presenter is Mr. Muhammad Alif Haikal. Okay. Mr. Muhammad Alif is here. Mr. Muhammad Alif Haikal bin Muhammad Ruzi. Are you here?
Oh, sorry.
Okay, you are here. All right. So, Mr. Muhammad Alif Haikal from Department of Civil Engineering, Faculty of Civil and Built Environment from UTHM is going to present his research topic on shear strengthening of reinforced concrete beam using a fiber reinforced polymer. So, this is a review study. So, please proceed, Mr. Muhammad Alif. This virtual floor is yours.
Okay, thank you. Okay, Assalamualaikum and good evening to ladies and gentlemen and to my beloved lecturer. I am from UTHM. Okay, today I will present about shear strengthening of reinforced concrete beam using fiber reinforced polymer, a critical review. Okay, before I start, I would like to thank to my supervisor, Dr. Syed Jamaluddin Hakim, because give me an opportunity to participate in this conference. Okay, let's we go for the slide. Okay, the shear is probably cause of a structure defect. Like we know, first of one is soil problem. Second one is lack of proper structure detailing. The third one is construction error. The fourth one is the use of effective material, and the lastly is lack of maintenance. Okay, why we need strengthening? In the first one is error in design stage. For loading specialization, material specialization, and change in code. For the construction error, poor construction practice, poor workmanship, and lack of proper supervision. For a service stage, is because of overloading, environmental factors such as seismic load. Okay, fiber reinforced polymer (FRP) is a composite material made of high strength fiber and a matrix for binding the fiber to fabric structure shape. FRP has been one of the major ingredients to be used in the construction industry to increase the strength of concrete structure. It can be used as a way to improve the strength of current framework that was installed a year ago, as it can be implemented externally. Okay. This picture shows a fiber type and matrix type. These three type of common fiber type, such as carbon, glass, and aramid, and two type of common matrix type, epoxy and esters. For the significant advantage of FRP, it has a high tensile strength, low weight, corrosion resistant, easy of application, and high life service limit. Fiber reinforced polymer (FRP) are used to enhance the behavior of structural component in inertia or flexure, repair of reinforced and pressed concrete element, retrofitting of beam, column, slab, and wall. Okay. Comparing carbon fiber to glass fiber, it can be seen that carbon has a fiber content and density that is suitable in the range of material with typical presentation of it, like we can see in this image. Below, when compared to the other two composite material, carbon has the greatest longitudinal tensile modulus and tensile strength of the three. Okay, this is a typical strengthening system detail. Like can we see it, they have a shear strengthening with FRP, fractional strengthening with FRP, and axial strengthening with FRP. Okay, for the problem statement, a substantial amount of research has been conducted on structural member to identify the improvement in their fracture and axial capacity due to FRP strengthening. However, an extensive review of previous study on the analytical and experimental work on shear strengthening with FRP system is limited. A study based on different Encore system effect the shear strengthening of FRP was required. Identification of the parameter affecting the shear capacity provided by FRP and evaluate the accuracy of analytical model was necessary. The objective is to review the available technical literature on the effect of different Encore technique on shear strengthening using FRP, the effect of different parameters on the shear strengthening using FRP, and lastly is the effect of RC beam strengthening with FRP in failure mode. Significance of this study is due to their lightweight, high tensile strength, and easy to install on irregular surface. The use of FRP system for the repair and strengthening of reinforced concrete structure has become one accepted practice within the civil engineering community. FRP system have a promising future in civil engineering applications such as the improvement of RC structure among other things. FRP system enable practitioners to apply the strengthening method to any surface, whether it is flat, curved, or geometrically uneven. Okay, this effect of different encourage technique on shear strengthening. For the first one is near surface mounted NSM encourage technique. Okay. The NSM FRP technique has several benefits over externally bonded FRP technique, including improved bonding efficiency and reduced exposure to the hostile environment. Okay, the NSM increased the FRP shear contribution by a significant amount, and the NSM FRP technique strengthening efficiency is sustainably determined by the bond behavior of the NSM FRP reinforcement and the part to be reinforced. And this one is FRP extension encourage technique. The use of FRP externally applying it is simple approach that significantly show the debonding of longitudinal FRP layer, hence increasing flexural capacity. Research by Dinop and Chang provide a new approach for alternating by beam soffit prior to FRP wrapping. This approach is intended to increase the strengthening efficiency by delaying premature debonding and eliminating stress concentration. The fact that this Encore method is simple and inexpensive. For the steel plate anchorage technique, steel plate use a mechanical anchorage in externally bonded reinforced fiber composite. Is perfect the most apparent method of preventing premature debonding. According to the result, steel plate anchoring is the first method for anchoring fiber reinforced polymer shear strengthening beam. Asato et al. Okay, the steel plate anchoring substantially increased the shear contribution of the fiber reinforced polymer, and in certain tests, the failure mechanism of FRP rupture was discovered, and despite this long-term corrosion of steel plate continued to be source of contamination. And then is steel bar anchorage technique. The anchorage steel bar, which are integrated with the original structure part, make the overall structure system more trustworthy and improving the structure bearing capacity. Besides, the fact that this anchoring technique enhanced the shear contribution of the FRP, it was unable to prevent the FRP from debonding from substrate, resulting in 45-degree inclination. For a sandwich plate anchoring technique, sandwich plate system have been shown to have high strength to weight ratio, which has led to an increase in their use in the design of the beam. Glass and carbon fiber, steel, aluminum, and other metal, as well as laminate composite, can be utilized to make sandwich plate depending on environmental and stress circumstances. The sandwich equilibrium method also substantially increased FRP shear contribution and in certain cases, avoiding the FRP debonding failure mechanism. This is a reference that I use for the research. And next we go to the effect of different parameters on shear strength using FRP. For the beam depth, we increase the depth for the NSM and metallic equilibrium method. The shear strength of FRP tend to decrease. Increase in FRP shear strength and FRP strength are achieved via the FRP extension and spike equilibrium method when used on deeper beam. The higher the FRP shear contribution, the deeper the beam and the larger the bond surface must be in the beam. For all Encore specimen, FRP debonding was the failure mechanism for all Encore specimen when the beam depth exceeds 450 mm. Okay. For the shear span to effective tear ratio, the distance between the load and the nearest support is known as the shear span. To determine if slender beam have a shear or flagella fracture, the A/D ratio is necessary. FRP shear strength appears to decrease as the A/D ratio increases for the various anchoring technique. Using FRP for shear stiffening becomes less applied as the shear span to effective tear ratio rise. The significance of the shear span to effective tear ratio in determining FRP shear strength contribution is not addressed in the current FRP strengthening design standard. And let's go to the concrete compressive strength. The FRP shear strength increases with the value of concrete compressive strength. For spike and correct approach, the FRP strength tends to decrease correspondingly with increase of concrete compressive strength. The failure mechanism for concrete compressive strength larger than 35 megapascal in the database provided there was FRP debonding. There is no significant explanation for this phenomena because increased concrete compressive strength is supposed to prevent FRP debonding failure and prevent concrete crushing in the compressive zone. This reference that we use. And let's go to the failure mode of FRP. Externally applied FRP failure mode. The goal of this study was to explore the uses of carbon fiber reinforced polymer (CFRP) as an externally applied beam material. Carbon fiber reach their maximum strength value and shatter at this point, which is the point of highest stress in the structure. The second form of failure is the bonding of carbon fiber reinforced polymer (CFRP) opposite. CFRP debonding. When tested in debonding mode, it found that almost all side bonded beam and the vast majority of U-wrap beam failed. The axial stiffness of the applied system has an impact on its tendency to debond from the surface. The CFRP sheet are able to withstand shear stress after they have been debonded locally. One of the most significant factors that may influence by this factor is the compressive strength of the concrete. A concrete fracture results in localized CFRP material debonding at the crack site as a result of the fracture. Let's go to CFP rupture. A CFP rupture failure mode would be predicted for CFRP laminate that is very thin and raw. It is necessary for local debonding to develop over shear fracture before tensile pressure can be applied to the CFRP material in order to achieve CFP rupture. As the fracture gets larger, the strength of CFP reaches its maximum value and the material rupture. If stress concentration are found inside the laminate, tensile fracture of CFP strip may occur at the lower stress than the material's tensile strength, which is called the tensile fracture of CFP strip. So let's go to failure mode of Encore. FRP debonding failure occur in all specimen type with FRP rope during concrete crushing, indicating that the FRP was debond. Data show that debonding failure is the most frequent failure mechanism for NSM and FRP spike equilibrium method, which debonding failure being the second most common. The failure mechanism of FRP rupture is characteristic of horizontal and insertion equilibrium method. Debonding was shown to be cause of failure in 56% of the 11 specimens that were secured using the metallic encouragement method. The average percentage of FRP shear strength for each of the different Encore method examined in this research is about 80%. The FRP rope Encore method followed by sandwich plate and FRP extension Encore technique provide the highest FRP shear strength. The lowest FRP shear strength was achieved when horizontal FRP and extension and spike Encore method were utilized in conjunction with each other. The expansion of FRP shear under the flange has been shown to decrease the shear strength of FRP sheet and to increase the likelihood of FRP deployment failure. This the graph from the Kodak et al. And it shows that the number of specimen over the type of anchorage technique. Okay, for the conclusion, from the literature review, it can be concluded that different anchorage technique give different impact on the shear strength. For example, the NSM FRP method has the potential to increase rebonding efficiency, but also reducing exposure to adverse environment. As a result of research on the effect of different parameters on the shear strength, it demonstrates that with increased beam depth for NSM anchorage method, the shear strength of fiber reinforced polymer FRP starts to decrease. As a result from the study on the failure mode, strengthened with FRP shows only a few Encore methods have been successfully in generating FRP rupture or fractural failure mode. For the recommendation, there are need a further research to improve the interaction between the parameter and the FRP shear strength and FRP strength and also the failure mode that occur by using Encore technique. Further study and analysis are required in order to quantify and better understand the process involved with the usage of externally bonded FRP system for shear application. And lastly, the design standard should be developed to result in more cost-effective, simpler and safer use of FRP for shear strengthening. Okay, that's all for me. Thank you.
All right. Thank you very much, Mr. Muhammad Alif. So I open for any questions to Mr. Muhammad Alif. I believe mesti Dr. Nurwidawati because this is her expertise. All right. Silakan.
Okay. Assalamualaikum, Muhammad Alif.
Waalaikumsalam.
I have two questions. In your slide, you mentioned earlier that A over D, it gives effects on the failure, whether shear or flagellal. So from your review, where are the boundary that what are or what are the value of A over D that will give shear failure, and what are the value of A over D that give failure for flagellal? Okay. Second question, for the UREP beam, which failure will occur first, whether debonding or rupture of the FRP? Okay, thank you.
Okay, thank you for answering question. For give me a question. Okay, for the first one, for the first question, they are limited in study when I studies on this paper. Okay, for the value of for the values of what the third can I revise
A over D.
A over D. Okay, for the value of A over D, I did not this is out of my scope study actually because I did not go through very deep on this value.
Okay,
Okay,
it's
for the
okay.
for the second one, okay, before it's always be debonding first before rupture appear, and this when we open a paper and we and I can conclude that before begin the rupture, the debonding, we can see the beam have been debonding first, and then in like uh, not so long, the rupture will begin after that.
Okay, that's all.
That's
Yep.
Okay, Mr. Mawali, please stop presenting. We are still seeing your screen. Okay, so basically it's good if you can put some of the case study in Malaysia, okay, so that we can see some of the examples using this kind of FRP. And then maybe it's good to have some illustration of the figure so that we can see those explanation more clearer. Okay, so I think that's all for today. Is it? Yeah, because Dr. Norwidawati is coming. Okay, yeah, Dr. Said, please.
Uh, just I add something to this current presentation. Actually, in the work also he mentioned 3 case study related to the first about the different anchorage, different parameters, and also different mode shape. So we did. And about this ratio, we consider this ratio bigger than 2 for normal beams and less than 2 for deep beams. The ratio of A over D. So, okay. Thank you very much for your good question, Dr.
Okay.
Durvidrawati.
Thank you,
Thanks a
Dr.
lot.
Said.
Thank
All
you.
right. Thank you very much
You're
for
welcome.
additional explanation there. Okay,
Thank you.
so we'll end up our presentation. Boleh, Dr. Nurwida? Tak boleh So
Boleh,
kita ada lagi.
boleh.
Kita ada last presentation by Dr. Nurwidawati. Okay, so I would like to present our last presenter, Dr. Nurwidawati from Faculty of Civil Engineering and Built Environment from UTHM. So she will give a presentation on a research title, Flexural Capacity of RC Beam with Opening Strengthened Using SCRP. Okay, sorry, SFRP. So I think without further ado, please, this virtual floor is yours.
Assalamualaikum and very good afternoon, everyone. My name is Noridawati binti Ali, and I will be presenting our research topic with the title of Flexural Capacity of RC Beams with Opening, Strengthened Using CFRP Sheet. And I will go through on the introduction and then methodology, experimental results, and lastly the conclusion. You see my slide moving, right? It is not freeze.
Yeah, it's good.
Okay. All right. As an introduction, why this study is conducted? Okay. Opening in RC beam is common. It is not something that is rare. Not something that is very new. Because it is essential to allow utility line to pass through the structure. However, this opening caused a sudden change in the beam cross-sectional area, and therefore it will easily cause crack around the opening. Okay, and FRP has been seen as one of the way to increase the beam capacity. Therefore, this study is conducted to investigate the behavior of reinforced concrete beams with opening strengthened using CFRP sheet. So what we did is we cast and tested 5 beams where 2 of the beams were strengthened using CFRP. So we have 5 beams. The first beam is control beam. We call it as SB. This is not strengthened and there is no opening for SB. Second beam is CBOC, beam with circular opening. Or maybe I can show you this slide here. The second beam is CBOC, beam with circular opening. And the third beam is CBOCBI. CBOCBI is beam with circular opening, but we strengthen using CFRP sheet. And at the midspan area. And the fourth beam is CBOR, beam with rectangular opening. And lastly, SBORBI, beam with rectangular opening, and we strengthen using CFRP sheet. So the specimen details, the size of the beams is 200 mm width and 250 mm height with 2000 mm total length. This brings the effective length of the beam is 1700. And the size for the circular opening is 150 mm in diameter, while the size for rectangular opening is 150 times 200 mm. The size of main bar is only 10 mm because we designed the beam to fail in flexure. Because we want to study the flexural capacity, so we want to make sure the beam fail in flexure so that we can study the flexural enhancement capacity. And the stirrup used is R6 100 spacing. And the strengthening material used is bidirectional CFRP sheets. As for the experimental results from this table, you can see that SB recorded 63 kilonewton, while CBOC and CBOR both beam with opening but not strengthened. CBOC recorded 63.5, while CBOR recorded 58 kilonewton. And for the strengthened beam, CBOC, the circular beam that we strengthened, it recorded 71.5 kilonewton, and this is increment for about 14% compared with the unstrengthened beam. For SBORBI, it 9.5 kilonewton with a 10% increment compared with the unstrengthened beam. From this table, we can see that CBOR here, beam with rectangular opening, it shows the lowest load carrying capacity with the highest deflection value compared with the other specimen. This is due to the stress concentration at the four edges of the rectangular opening. And from these results, we can also see that the presence of CFRP at the opening was able to improve the flexural capacity and reduce the deflection of the beam. About the load deflection behavior, the trend here is for all specimen, it shows the same pattern. Okay, for strengthened beam, for the opening, it does not give any much different in terms of the load deflection behavior. However, if we go a little bit further, more details here, the CFRP has contributed to the increment of the stiffness of the beams for the strengthened beam. And these are the crack patterns and mode of failure of all beams. And basically, the crack propagation for all specimen is almost similar, where all crack at the beginning of the loading started at the soffit of the beam, and then it goes to the point load location. And the difference is for strengthened beam, of course, we cannot see clearly the crack propagation at the CFRP area because there is CFRP here, there. So we cannot observe what happened at inside or at the face of the concrete. But based on the beams without CFRP, CFRP, we can see that at the opening there are a very big crack that can be observed at the opening there. And this CFRP has improved the performance where there is no much crack at the area, and there is no major or big crack observed at the area of the opening. Okay. So as the conclusion here, the crack pattern of strengthened beam was significantly decreased without the presence of the concrete crushing. So as for the conclusion, CBOCBI, this is beam with circular opening, and we strengthen the beam. It has achieved the highest ultimate load among all of specimen, and this is relevant to the expected result of this research, which is the beam with circular opening was able to reach higher load carrying capacity compared with the rectangular opening. This is if we compare between the two types of opening, circular and rectangular. Rectangular opening will achieve lower load because of the four edges. Okay. A second conclusion is the presence of CFRP sheet as strengthening materials has increased the load carrying capacity of the beam from 12.6% to 19.8%. And last but not least is less crack can be observed occurred for strengthened beam due to the presence of CFRP sheets. And that's all from me. Thank you, everyone.
All right, thank you very much, Dr. Nurwidawati. So I open for any questions from the floors.
Assalamualaikum.
Waalaikumsalam.
Waalaikumsalam.
Could you introduce yourself?
Thank you to Dr. Nurwidawati for the nice presentation. I have one question. So how you design the opening size? Or how you decide the opening size?
Okay. From previous study, there is the guidance that gives whether we want the opening to be a small opening or big opening. And previous 2 years maybe we have done a beam with a small opening, and we didn't see that much effects on the beam's performance. And therefore in this study here, we use a bigger size of opening, which is around 60% from the total area of the beams, and 60% is we can call it, or we can group it as a large of opening. The size of the opening, basically there is no specific guidance about the size of the diameter, the size of the rectangular opening, but it counted as the cross section area, how much is the percentage that is lost due to the opening. And from our study, the percentage of loss area due to the opening is about 60% from the 150 mm diameter, and the rectangular opening of 150 and 200 mm. We have lost about 60%. This is at the opening area only, not throughout the length of the beam. At the opening area, we have lost about 60% of the
All right. I hope those questions those answer has been satisfied. Okay, Dr. Said. Okay.
So just I have a small question about the configuration of FRP sheet, including the coating, maybe layers. Can you just
Okay. For this study, we do 4 four in four sites. But
4 layers.
yeah, we don't want have we wrap it in four sites. What are the other one question? Do you have
No,
another
this
one
is just
question?
question. So
Okay.
when you put a more layer, of course, the value of deflection will decrease.
We just use one layer only.
Oh, one layer.
Yeah, one layer.
Okay. Okay. Thank you very much.
Okay.
All right. Any more question before I ask Dr. Nur Widawati? Seen the PowerPoint bedding test that they put the spacing L/3, but then based on your experiment, we just put between the two nodes of the point load is about 300. That is my first question.
Yep.
So in
What
terms
is the
of the
question again?
experimental testing procedure, I ever seen that for the 4-point bedding test, the spacing that they use is L/3 because you are using 4-point bedding test, right? So meaning that L/3 is about maybe equal spacing. But then now you are using 700 and then the point load between two point load there is 300 and then coming back to 700. Okay, so maybe you can explain on that. And then my second question, based on your experiment last time, so what is the maximum deflection approximately for the first crack? Do you have any ideas approximately when it comes to the first crack, what is the deflection?
The deflection.
Because this deflection is based on the failures, at the failure mode.
Yeah, but I don't think we observe the deflection at the first crack. For the first question, why we arrange the location of the point load that way, first we considered as the A/D. Since we want to study, we want to make sure that the beam fails in flexure. One of the condition that we considered is the A/D. So we choose the A/D that is more than 2.5, and from that values, we come up with that length of beam 1.7 meters. That is the only that is the scope of we have determined that we cannot get more like 3 meters beam. So with that limited length, and we want to achieve the flexural failure, and we don't want it to be a shear failure. That's how we determine the location of the point load and location of the support.
All right, thank you very much for your kind explanation just now. Okay, any more questions from the floors before we end up our session?
I have a question.
Okay, boss.
last time. All right. Thank you, Dr. Wirda, for the good presentation. So I just want to asking about the FRP that you have been using in your repair. Any monitoring system you have done to check whether they have delimitation between concrete and also the FRP material?
No, we don't observe the delimitation, but we don't observe it. Closely. What we did is what we see is there is no debonding, there is no delimitation from the bare eyes, and that's why we try to avoid that debonding by using the full wrap, not U wrap.
Alright, so meaning the FRP is fully utilized lah
Mm-hmm.
in your study. Alright, okay, thank you very much.
All right, thank you very much. There are so many fans. Okay, Dr. Nowidawati, she has so many fans. Okay, now, so I guess that's all for now. Okay, so finally we come to the end. Okay, so I would like to say thanks again to all presenters for their informative and interesting presentation. And then hopefully this presentation will be beneficial for everybody. And then I think before we end our session, it is good if we can have a photo session. Could you switch on your camera so that we can snap a photo? Okay. Oh, ramai rupanya. Ingat tak ramai. Tak perasan ramai. Okay. So, thank you very much. Okay, any more? Ada lagi yang nak on? Okay, sebelum saya snap. Alright. So, sekejap ya. 1, 2, mana button? Okay, 1, 2, 3. Right, one more, sekejap ya. Banyak monitor ni, kiri kanan ni. Okay, so one more. Right. 1, 2, 3. Okay, so I think that's all for today. Thank you very much for your patience, and also is quite a good sharing today. Okay, even though we have only a few participants, but then it's good. It is a good sharing today. So I think that's all for today. Until we meet again, don't forget our GCOMSE next year. Okay, hope to meet you again for our next conference. Until we meet again, thank you very much. Stay
Thank you
safe.
very much, everybody.
Thank you,
Assalamualaikum
Dr.
warahmatullahi
Fahmi.
Thank you,
Thank
everyone.
you very much.
Assalamualaikum.
Assalamualaikum.
Terima
Bye.
kasih.
Assalamualaikum.
Thank you very much.